Hey everybody, welcome to CS3540. This is the introduction video. Real quick before we jump into the book, we want to go over a little bit about the book because it's formatted in a little different way. It's made for professionals and it's meant to be very engaging. So a few things, there's lots of images, it's very visual. You'll notice this, there's like a tagger. Your brain will think that's important even though it's the random tagger on page VIII of the book. It's very conversational and personalized. It's meant to get you to think more deeply, right? At Bowling Green State University, we focus a lot on metacognition. We actually want you to think about what you're learning and think about how you're learning it and why you're learning it. So this book helps support that goal. It also helps keep your attention. Supposedly, it will also touch your emotions. That's up for debate. It will definitely make you think about thinking, though. There's activities, there's engaging activities, there's repetition. It's all tricks that we use to help us remember things. You'll know this because people like me as an instructor, as a professor, we tend to repeat ourselves all the time. Why? Because repetition drives home concepts. Why? Because repetition drives home concepts. Okay? That's one of the things we're going to do in this class. So there are some tricks, and you'll see these are in your book too, that'll help you move through this book, learn software engineering better than if you didn't. Okay? Slow down a little bit. You should have a lot of time on your hands, so make sure you slow down and read. Do the exercises, write your notes, make sure you read the book, print them off if you need to, keep a blog, write Twitter posts, Instagram posts, whatever. Always read. There no dumb questions. We're going to go over a bunch of them, but they're really, really important, and they help flesh out the key topics. This could be the last thing you read before bed. We know that if you read and then fall asleep, you'll tend to remember more of it. Drink lots of water. I'm really bad at this. I drink lots of coffee, not lots of water, but water is good for the brain. Don't drink too much, just enough. You can also talk it out loud. I remember in college, I always had this problem where I would be facing a problem and need to solve it, and I would go to my professor's office. And before they could tell me anything, I would literally tell them the question, describe it to them, and then I would solve it because I was speaking out loud. So make sure you do that. It helps activate different parts of your brain and change the learning process. Listen as well. This is going to be a semester, and some semesters are like this, others are not, where you may or may not be overloaded, so pay attention to your own mental and emotional state. Do know that this matters. Get involved with it, make it personal. Write a lot of code. One of the things that I can recommend to every software engineer is just to write code all the time. I tend to say break it till it's fixed because I think the best way to learn is to dive in, get hands-on, and break things. Write code that doesn't work on it till you fix it, and then remember what you learned in the process of fixing it. And last, make sure you stick all these on your refrigerator or where it is on your mirror in the bathroom so you're reminded of them every day. Okay? So a few things. The book will assume you're familiar with object-oriented programming. We won't cover every software development process out there. We will focus fundamentally on the agile software process. Realize that you have to do the activities. These will be built into course discussions and other things. They definitely will be there. Redundancy is intentional. Everything in here is as bare bones as possible, so please remember that. They're not fully worked out real-world examples, but we will get into some of those with our assignments. And the brain power exercises don't have answers. Why? Because they are meant to be open-ended questions that have very few answers. They're meant to spur discussion and to engage you deeply. So that being said, you know what's in the book, so let's move on to the first chapter, Great Software Development. So we're going to build software. We're going to be software engineers. The first thing we have to know is the major concerns of every software project. That is building what's needed on time and on budget. Money, time, requirements. It's always a trade-off. You always get to pick two of the three, right? If something is on budget and on time, you may not get exactly what you need. If something is on time and it's also what you needed, it's going to be super expensive. It's likely not going to be on budget. So there's all these trade-offs. Through our book, right, this is what we'll be picking, okay? We're going to be working with Tom's Trails in this chapter and talking about this trade-off between time and money in building the website, okay? Now, if you were building this software, a lot of software developers, especially folks working on their own, would go off and they would do this big bang thing. right? They would do the big bang software development. What's that? Well, it's you go, you talk to somebody, they tell you what they need, you write the code, you pop it out, and you walk up and you say, hey, it's done, it's perfect, I am a software god. But that doesn't necessarily work now, does it? You do this, you throw all this stuff in, you have a big bang, and then something comes out. But there's problems with that. Okay, there's a lot of problems with that. You deliver software, but it really may not be what the client wanted. Because one of the hard and fast rules in software engineering is that if your customer isn't happy, you built the wrong software. That's something we always have to remember. We always want to aim towards two things: building the right software and also building the right software the right way. Okay, so software needs to meet the requirements. It needs to be functionally correct. And it also needs to function properly, which means it doesn't fail when you're testing it and things like that. So this is very important. For the Big Bang method, the emphasis is that you think you're finished. Okay? One thing I will tell you, and if you noted in our previous lectures, software is never done. Okay? Software is always evolving, always growing, always changing, always building. One of the reasons that you may do this whole thing, the Big Bang, and then come out with the wrong product is because of something called interpretation. You see, every one of us wears our own set of glasses, whether you know it or not. So everything you hear and see and think and feel in the world is filtered through your own lens, right? And this is what we call interpretation. We don't want to interpret what our clients need. Okay? If you're not sure, ask a question. Drop a text message, hit them up on Slack, email, phone call, drop by the coffee shop, whatever that is. But you always need to keep the customer in the loop at a reasonable pace. Okay? Some Agile folks will say the customer should be part of the team. They should be sitting there with you. No, absolutely not. The customer should not be sitting there with you. They will be looking over your shoulder. They will be nitpicky. They will be crazy. But having regular meetings, maybe once a week, once every 2 weeks, so that you can constantly ask questions and get feedback. Now that is key to keeping your customer in the loop. So that being said, remember that the software that you want to build is what is needed, right? What's on time and what's on budget. Okay? This is really important. So what's the key to hitting these marks? Well, one thing we found is that for normal everyday software, so please understand, the Agile method has not been demonstrated to work real well with things that need a very high safety rating, for a better term, right? So I would never recommend using Agile software development to build software for a plane or for a rocket. Okay, there's different methods of building software for those systems that will keep them more robust, and they just can't change, right? If you change the software on a plane every 30 minutes, something is going to go wrong. How do we know this? Well, think of your smartphones. Those apps update all the time, right? Overnight, on the weekends, during the day, they may update 2, 3, 10 times a day. Why? Because something goes wrong, they find a small fix, apply it, and they update it. Does it matter to you? No, because it doesn't do anything big in your life. But if you're on a plane and the software updates and there's a small bug on it, that small bug may make you crash. That's a big deal. That costs lives, and there's different methods to handle that properly. So when we're building our normal software, right, for phones, for the web, for enterprise systems, all this kind of thing, what's the key to great software? It's iterations. Iterations are really, really simple. All an iteration is that you slowly, in small increments, work on focused sets of tasks for your software, get them to working and tested, get feedback on them, and then continue to add and to build. Okay? The thing that makes an iteration is that it starts, it ends, and there is some kind of checkup at the end. So some questions to ask. What if I'm sure that I know what the customer wants at the beginning of a project? Do I still need to iterate? Yes, of course you still need to iterate. It helps keep you focused, it brings up new ideas, it keeps everything on track, and it keeps the customer involved. The customer's ideas may evolve as well, so you need to be ready to pivot, and a stopping point at an iteration every 1 to 2 weeks gives you that pivot point. Your project's only 2 months long. Is it worth iterating? Yes, for all the same reasons I just said. Wouldn't it just be better, No, absolutely not. Okay, here's why. We've done this. It just doesn't work. It's called the waterfall method. You do all the requirements at the beginning. You do all the meetings. You write up this functional document, the specifications. You do all this front end work and documentation and planning and blah, blah, blah. And then it all gets screwed up. So what's better? Gather all these things slowly over time with frequent updates. And it doesn't mean you don't build this documentation, right? Requirements docs, spec docs, functional spec documents, they're all great to have. But they should evolve slowly over time and not be written once and then written in stone. Okay? You always have to iterate. Let me say it again. 20 to 30 working days is ideal here. Many people iterate on a shorter schedule. Very few do a longer. I prefer about 1 week iterations myself if I'm working on software, so about 5 working days, which I think is a really nice thing. At the end of every iteration, you have to produce working software. So if it's a website, you have to be able to view it. If it has buttons, they have to be clickable. If it's an app, it has to be installable and runnable. And you have to demonstrate that. And the software also has to be of quality, right? You have to test it. It has to work. It has to work well. So what's in every iteration? You get your requirements, you design what you're doing, you write code, and then you test. You take that, you do it again. You produce a working product, that little box above the arrow. That working product goes into your next iteration, where you get more requirements, design, code, test. You get a bigger product. You do it again. You do it again. You do it again. And the product continues to become more complex and more fully fledged, more requirements. Everything's there until finally you have a final working product, which is never actually really finished. So who should be involved in an iteration? The answer to this is everyone that should be, all necessary stakeholders. You'll hear different terms here. It's the dev team, it's the client, it's the product owner, all these things, and we'll talk about these roles more as the semester goes on. Does a team of one need to iterate? Absolutely. It keeps everybody organized and accountable, including your client. How early in the project should you start iterating? From day one, no questions asked. And what happens when your customer comes back with bad news saying, I'm way off what I'm building? What do you do then? You move. This is agile, right? One of the things you will hear me say repeatedly in this class is you do not do agile, you are agile. If you're agile in real life, if you're athletically agile, it means you can move quickly. You can jump back and forth. That's the same thing. If we work in small iterations, it gives us tons of leverage to be able to shift our software development processes. All right? So we have all these iterations going on, right? You see this, right? There's a simple portion of a website. It's good. Tom says, hey, but can we change the rounded tabs? Oh, and I'd rather change some names. This is awesome. This is exactly what you want, okay? Small pieces, feedback from the client, change. So how do you do it? You'll find out that we will start using things called user stories in the next lecture. But for now, we just start listing features, right? You can do something like log in. I think that's going to take me 2 days to write, and I have a customer priority of 30. Or buy equipment. That's a feature. Maybe not described real well, but a 10 means it's really critical. Okay? Another thing, well, hey, list equipment, 7 days, it has this, there's a customer priority. One thing you do want to remember here is with priorities, okay? These are a challenging thing for most people, but we tend to separate them by values of 10, and there's different systems that we can do this with. But by 10, because by separating them with 10, it gives you enough mental space where you always think, well, 30 really is less important than 10, as opposed to 1 being less important than 3. 1 and 3 are so much closer that mentally it's hard for you to differentiate, but that large gap between 10 and 30 gives you that kind of space. So, the last feature scheduled for my iteration will push the time needed way over a month. What should I do? Easy answer. Tell your client, push it to the next iteration. Ordering by priority is good, but what happens when there are dependencies? Well, guess what? Dependencies always take priority. If something you're working on requires you to implement something that's later, you have to get that done first. You shift around and do it first. Does adding more people to the project lead to more work completed or less time for each iteration? Not necessarily. We find that in software engineering, the ideal team size, the ideal maximum team size is about 7 people. 5 is a really good size of a team to work on things. Over 7, everything slows down, communication takes hold, and it is a mess. Smaller teams tend to work slower in general, but the best teams are teams that are about 5 to 7 people and have also worked together for a long time. The longer you work together, the better you are at working together. What do you do when my plan needs to change? Real easy. Call the client, right? So you'll see here we have Tom. I think it's really important that Tom's Trail has a mailing list, right? They want to change things. No big deal. Write up some more features, organize this, right? 3 new features with this, but there are some problems, right? Can you get it in here? Sure, estimate the features, prioritize the new features, rework your iteration plan, and then check your project deadline, right? No big deal. You estimate these, okay? Throw in the new estimates, you add estimates. You have the customer prioritize the features. What's most important to the customer? Always remember, priorities belong to the customer. Why? Because it's their product. If they want something in it, it's their right to say, hey, this is my product. I need this feature more than this feature. Can you try to talk them out of it? Yeah. But at the end of the day, you do what your client says because they're writing the check to pay your salary. Okay? So you want to get these in. The only time you can take precedence is when there's a technical dependency that requires you to do something of a lower priority earlier. Okay? After that, you rework your iteration plan. So here you'll see we have a basic iteration plan. You have some different features at the front and different things. The iterations are split by these dashed lines. You shuffle them around, and then you check the project deadline, right? You know when you're supposed to be done. You take the days of work remaining, you subtract the days left, and you see what happens. Okay? If it's negative, you're in good shape. If it's positive, you might be in trouble. Okay? So this is the most basic Agile process that we can work with. Iterations, features with priorities and estimates in this iteration plan. Okay? The one thing I really want you to take away from this lecture is that the right software development process for you is the one that helps you develop and deliver great software on time and on budget. This is really important to remember. The Agile methodology, which we'll be talking about here, is not really a methodology, it is a philosophy. You'll hear things about Scrum and extreme programming and this and that and Lean and all these methodologies. Agile software development is about finding the best process, people, and tools for you to build the best software. If you modify them, that's awesome. Whatever works best for your team, go with it, roll with it, run with it. Why? Because you don't do Agile, you are Agile. Agile is a philosophy that we will build on as this semester continues to work through. Okay? So your software isn't done until it's released. Everybody's excited. We're moving forward. And we will very soon be moving forward into what it looks like to gather requirements in a very real way for the Agile methodology. So takeaways here. We have a process. This is the basic Agile method. We are going to work with our client. We are going to get features. We are going to do iterations, and we are going to build great software. We'll see you soon.